In 1884, workers in Chicago were stacking a 10-story tower on outside walls barely a foot thick. The city was so sure it would fall that inspectors climbed the half-built frame and ordered every man off the job until it could be proven safe. So what was keeping it up, if not the walls? That question took nearly 50 years and a wrecking crew to fully answer. And when they finally cracked the building open, what they found inside rewrote the history of every tall structure built since. Partway through construction, a steel salesman from Pittsburgh had talked the architect into a swap that would land this plain little office block in every architecture textbook, almost by accident. And the man who designed it spent the rest of his life telling a story about it that was never quite true. I read Jenney's 1885 write-up, the demolition reports, and the original building permit, and used advanced AI to reconstruct how it went up, floor by floor. This is how the home insurance building in Chicago was built. The story starts 13 years earlier, and it starts with fire. On the night of October 8, 1871, a fire broke out on Chicago's west side and did not stop for 2 days. By the time it burned out, more than 3 square miles of the city were gone. 17,000 buildings reduced to rubble, 100,000 people without homes, and the entire business district essentially erased. What grew back in its place was different in almost every way. Taller, denser, and built on ground that had suddenly become the most expensive dirt in America. The combination, cramped land, explosive commerce, and the memory of everything burning, pushed Chicago's architects hard toward height. And height, in the early 1880s, meant masonry. Every tall building of the era stood on its outer walls, the stone and brick carrying the floors, the roof, and the full weight of everything stacked above. At 3 or 4 stories, that system built an empire. At 10, it started eating itself. The arithmetic turned cruel fast. The wall at street level has to carry everything above it, which means the taller you build, the thicker the base has to be. By the time you reached 10 stories, you were looking at 4, 5, sometimes 6 feet of solid brick at the ground floor. And that brick cost you twice over. It consumed the most valuable real estate in the building, the ground floor where rent was highest. And it forced every lower window down to a narrow slot, because a wide opening in a load-bearing wall is a structural weakness you cannot afford. Taller meant darker, heavier, and less floor to sell. The Home Insurance Company of New York walked straight into this problem. They wanted a Chicago headquarters that was tall, fireproof, and packed with small, rentable offices full of working light. With masonry, those 3 requirements fought each other at every turn. Someone had to find a way to make the outside wall stop doing the heavy lifting, and in 1883, they handed that problem to William LeBaron Jenney. The engineering concept behind the home insurance building did not start with buildings at all. It started with bridges. Jenney had spent the Civil War designing military bridges for Sherman and Grant. And a bridge is a skeleton structure laid on its side. The load travels through an iron frame, not through solid mass. The bridge does not work because it is heavy. It works because its members are positioned to carry force efficiently, compression where the material is being squeezed, tension where it is being pulled. Iron handles both. Stone handles only one. What Jenney did in 1883 was stand that logic upright. A vertical iron column works exactly as a bridge pier does, taking the load straight down through compression. A horizontal iron beam works as a bridge span does, spanning between columns and carrying the floor above. String enough of these together, and you have a 3-dimensional frame that can carry a building's entire weight through iron, floor by floor, all the way to the ground, without asking the outer wall to do anything structural at all. The idea was not entirely his alone. Frederick Baumann, one of Chicago's leading construction theorists, had published a pamphlet in March 1884 laying out the same iron frame principle, and his earlier work on foundation engineering had already shaped how Chicago builders thought about transferring load through soft ground. The concept was circulating. What Jenney brought was the willingness to build it at full scale. 10 stories above LaSalle Street, on some of the most expensive ground in America. Before he could raise a single column, though, he had to solve the problem that sat underneath all of it, the ground itself. Now, Chicago sits on soft, wet clay, compressible soil that behaves less like rock and more like a firm sponge. Press one spot harder than the spot beside it, and it sinks unevenly. Builders had a name for the nightmare: differential settlement, and it was cracking buildings all over 1880s Chicago as heavy piers sank faster than the walls between them. An iron-framed tower made this worse before it made it better, because the frame gathered the building's whole weight onto a handful of columns, each driving its load into a small patch of that sponge. Load them unevenly, and the tower would rack out of square as it settled, cracking floors and jamming doors. So Jenney did not start with iron. He started underground, spreading the load on isolated foundation piers, a separate footing under each column, each sized so a heavy column and a light one would press the clay and sink at the same rate. Match the settlement and the frame goes down together, level, instead of tearing itself apart. There was no reaching bedrock. It sat far too deep to dig for, so the footings floated on the clay itself, each spread wide enough to carry the column above it. The irony I keep circling is what he chose to brag about. When Jenney wrote up his building in 1885, he led with the foundation. The thing he put first, the one he was proudest of, was the part no one would ever see. The steel that made him famous he barely mentioned, and he never once called the building a revolution. With the ground pinned, he could start stacking the cage. They pulled the permit for a $300,000 building and broke ground on the 1st of May, 1884, at the northeast corner of LaSalle and Adams. The frame went up as two metals doing two jobs, and knowing which is knowing how the building stands. The vertical columns were cast iron, superb in compression. It loves being squashed straight down, exactly what a column does all day. The horizontal beams were wrought iron. A beam sags in the middle under load, so its bottom edge stretches, pulled in tension, and wrought iron takes that pull far better than brittle cast iron could. Right material, right direction. The columns stacked story by story, each landing on the head of the one below and bolted through the joint. The beams tied them into a rigid grid floor by floor, so the whole thing rose as a self-supporting skeleton before much of the wall existed. That let crews work inside the frame while masons filled the walls below, a big reason the schedule beat masonry. The cast iron columns on the street sides were then wrapped in masonry, and that brick was mostly there to protect the iron from fire. Bare iron softens and buckles in a serious blaze, and the whole point of the job was a fireproof building. The stone made the tower look massive and traditional from the sidewalk. Inside, it was a cage. The frame was climbing fast. Then a letter arrived from Pittsburgh that would hand this building its place in history, more or less by accident. The famous part of this story gets it backwards. Jenney did not set out to build with steel. His plans called for wrought iron beams the metal builders had trusted for decades. Partway through construction, the Carnegie Mills came to him with an offer. They were rolling structural beams out of Bessemer steel now, and they asked him to swap steel in for the wrought iron on the upper floors. Jenney said yes. That yes is the entire reason the textbooks call this the first large-scale structural use of steel in a building. What gets me is how little drama there was in the moment. Steel and wrought iron of that era behaved so similarly under load that the switch changed almost nothing about how the building worked. It was a supplier moving new product, not an architect chasing a revolution. The famous steel skeleton started as 2 floors of beams stamped with the Carnegie name that happened to be steel instead of iron. And it was only the upper floors. The structure below stayed iron, so the building people picture as a gleaming steel frame was really a hybrid, iron down low, a little steel up top, hidden inside stone. That gap between the myth and the metal is the whole story of this place. Meanwhile, up at street level, the walls were going up so thin that the city of Chicago started to panic. Once the frame carried the load, the wall had almost nothing left to do, and that changed what a wall was allowed to be. In a masonry tower, the wall holds up the building. In Jenney's tower, the frame held the building up and the wall just held itself, one story at a time, each floor's stone resting on the beams at that level like a curtain hung off the skeleton. That move names the whole idea, the curtain wall, and it let the exterior go thin exactly where old masonry had to go thick. The payoff was measurable. The finished building weighed about 1/3 of the same tower in solid masonry. A third. You could read it in the walls, far slimmer than any 10-story building had a right to have, and in the windows, which grew wide and tall because a curtain wall does not need the deep brickwork a load-bearing wall lives or dies on. That lightness spooked the city. Officials looked at a 10-story tower rising on walls that thin, decided it could not stand, and halted construction to check it was safe. They studied it, satisfied themselves, and let Jenney finish. The home insurance building opened in 1885, 10 stories and 138 feet, the tallest of its kind on the block, which raises the question that would take almost 50 years and a wrecking crew to answer. Was it actually the first? Now the record needs correcting, because the honest version is stranger than the legend. A true skeleton skyscraper, by the strict definition, is three things at once. The frame carries everything. It has extra bracing built in to handle the wind. And the outer wall is pure curtain, carrying nothing but its own weight. Hold the home insurance building against that test, and it comes up short on all three. Only the two street-facing walls had embedded iron columns, and those columns sat inside masonry piers still doing real structural work. Some of the stone lintels leaned partly on brick, not purely on iron. Strip the facade away, and it would not have stood as a bare cage. It was an iron and masonry hybrid, a brilliant halfway step, not the finished idea people credit it with. That halfway nature mattered more than its sounds. The two interior court walls carried their loads the old way, through masonry alone, with no iron inside them at all. There was no wind bracing engineered into the frame. The building relied on the mass of its own stone to resist lateral load, exactly as a masonry tower would. What Jenney had built was a building that used skeleton logic on its street faces and fell back on traditional construction everywhere else. A genuine skeleton could stand naked. This one could not. In 1891, the building grew 2 more floors, pushed to 12 stories and 180 feet, the frame bolted upward on the same hybrid logic that had carried the original 10. The argument over what it truly was went with it, sealed inside the walls. Rival architects in New York and Minneapolis had their own candidates, and the fight over who was truly first got loud and stayed loud for decades. Nobody could settle it, because the proof was locked inside a building no one was willing to take apart. Until one day, somebody finally was. In 1931, the home insurance building was condemned and slated for demolition to make room for the taller field building. A group of architects realized the wrecking crew was about to crack open the one piece of evidence that could end the argument. So they ran an autopsy as it came down. A committee, including the architects of the replacement tower, studied the structure floor by floor while crews stripped it. They ran the decisive test in the open air, pulling the masonry out of an intermediate story to see what the floors above would do. Nothing happened. The upper floors stood there, carried entirely by the frame, with the wall beneath them gone. That is skeleton construction, proven by removing the wall and watching the building not care. Then they pulled the metal and read it like a logbook. Beams came out with the name Carnegie stamped into the steel. The investigators found steel in the upper stories and iron below, exactly the hybrid the old build logs implied. The U.S. Steel Corporation hauled one beam off to Pittsburgh for a museum, and a full 16 by 16-foot window bay was cut out and saved for an exhibit on the birth of the skyscraper. The committee delivered its verdict, and it went in the building's favor. The home insurance building was ruled the first of its kind, ancestor of the skyline. It earned the title in the middle of being torn to pieces. William LeBaron Jenney never lived to see how far his idea would reach. He died in 1907, but by then the future was already taking shape in his office. Daniel Burnham, John Root, and Louis Sullivan all trained under him before going on to reshape the skylines of Chicago, New York, and beyond. The architects who defined the modern city all started with the same lesson. The home insurance building proved something no one had proven before. A building no longer needed thick masonry walls to hold itself up. Put the weight on a steel skeleton, let the walls become little more than a protective shell, and height stopped being the limiting factor. That single breakthrough changed the future of architecture. Every modern skyscraper still follows the same basic principle. The original building is gone. It was demolished in 1931, and the field building now stands at LaSalle and Adams. Almost nothing physical remains of the world's first skyscraper. Just one preserved steel beam, and an idea that quietly transformed every skyline on Earth. The first skyscraper disappeared nearly a century ago. Its invention never did. If you enjoyed this story, subscribe for more deep dives into the hidden engineering and forgotten history behind the world's most iconic buildings. And let me know in the comments what I should cover next.